Hello everyone, welcome back to Pre-Algebra with Miss Betsy. What we're going to be talking about today is how we convert a fraction or a rational number to a decimal. We'll be defining repeating decimals and terminating decimals. We'll also give you the definition of what an irrational number is. If you're using the same text that I am, you can find our material today. We're in section 7.5. Page 230 of the text Pre-Algebra for Christian Schools. First edition is published by Bob Jones University Press. And I have a new lame joke book. And some of these are so lame that even I won't stoop so low as to do that. However, I have one for you right now. Where do you leave your spaceship when you visit another planet? Well, you leave that at a parking meteor. So let's go ahead and get started with this lecture today. It's very brief, very, very straightforward. How do you convert a rational number to a decimal? You do this by dividing the numerator by the denominator. The question says, write 3/4 as a decimal. See that this is a rational number because it has the form a over b. A and b are integers. B is not equal to 0. You recognize it as a fraction. We read this as 3/4 or 3/4. What does this fraction bar in the middle really say though? It's saying 3 divided by 4. So you simply do long division to solve this problem. You have 3 divided by 4. Now you remember that when you are trying to divide, can you count any groups of 4 out of 3? No, you can't. So you do what they call annex zeros. Remember the number 3 here? It's a whole number. You can add a decimal point and add zeros. Now this is 3.0. Now, as long as you're not talking about specific scientific measurements, 3.0 has the same value as just a 3. You ignore the decimal point when you're dividing, but you make sure that you put that decimal point directly up in the answer, the same location. 4 goes into 3 0 times. 0 times 4 is 0. 4 goes into 30 7 times. 4 times 7 is 28, and we're going to subtract. 30 minus 28 is 2. Well, we're not finished yet, are we? Let's go ahead and annex another 0, add another 0, bring that 0 down. 4 goes into 20 5 times. 5 times 4 is 20. When we subtract, our remainder is 0. When we have a remainder of 0, when we are converting a decimal to a mixed number, to a decimal, when we're converting a fraction to a decimal, we have a remainder of 0. This is what they call a terminating decimal. What does terminate mean? When something terminates, it stops. You don't have to keep on doing your division here. You got to a remainder of 0 and you are completely finished with your division problem. Your division problem has terminated. So if you're going to write 3/4 as a decimal, you would do that division and you would simply say that 3/4 is equal to 0.75. 3/4 is equal to 0.75 or 75 hundredths. You remember that the way that you name a decimal number is to read the digits to the right of the decimal point as if it were just a regular whole number, 75, and then you call the name of the very last place. The 5 is in the hundredths place, so this is read as 75 hundredths. Why is there a 0 here in the front? That 0 just screams at you that this is a number that's smaller than 1. It alerts you to the fact that you have a 0.75 and not just a 75. Because our division stopped, it ended, we ended up with a remainder of 0. This is what they call a terminating decimal. Can't divide anymore, your division terminates. You have a terminating decimal. Now, what happens if we have a division where it doesn't stop? Let's see what I'm talking about here. Instead of saying write the fraction 3/4 as a decimal, let's go ahead and write 5/6 as a decimal and see what happens. How do you write a fraction? How do you write a rational number as a decimal? And you notice I'm continually saying fraction, rational number, fraction, rational number. We want you to be moving from fraction into a rational number. We're going to divide 5 by 6. You're going to be able to do that by annexing zeros. 6 doesn't go into 5, but 6 will divide into 50 because 6 times 8 is 48. 8 times 6 is 48. When we subtract, we have a remainder of 2. We have to keep going with our division until we have a remainder of 0. So we're going to annex another 0. Bring it down, we have 6 goes into 20 3 times. 3 times 6 is 18. We subtract, we have 2 again. Annex another 0. 6 goes into 20 the same number of times. We subtract, and we have 2 again. So what do we see that's happening? Yeah, that we could keep adding zeros until Jesus returns. And we're still going to have 3 times 6 is 18 with a remainder of 2. So when you are dividing a fraction, dividing a rational number, to convert it to a decimal, if you get a number that just repeats forever, that's easy. That's what they call a repeating decimal. It does not terminate. But how in the world are we going to write this? We're going to say 0.83333333333. Well, no, that's dumb. And we're not just going to put this set of 3 dots here. This is called an ellipses. We're not just going to use the ellipses to indicate that that pattern continues forever. We're going to use what I've always called a repeater bar. And what we're going to do is draw a bar over only the digit that repeats. So we would say that 5/6 is equal to 0.83 repeating. This bar only extends over the 3 because the 3 is the only digit that repeats. So this means that 5/6 is approximately equal to, and the squiggle equals means approximately equal to 0.83333. It's going to continue on forever. Because this repeats, it does not end. It is not a terminating decimal, but this is called a repeating decimal. So we've had a terminating decimal. 3/4 is equal to 0.75. The division finalizes, it terminates. It's a terminating decimal. We have divided 5/6, and we see that the 3 repeats, doesn't terminate. We use our bar over the digit or digits that repeat, and we label that a repeating decimal. So rational numbers, when you convert them to be decimals, they can be either terminating or non-terminating decimals. So let's think about this. Make sure that we understand what's going on. Rational numbers written as decimals may be either terminating or repeating. Maybe first terminating, examples: 3/4 is equal to 0.75, 3 and 1/10 is equal to 3.1. Okay? They can be repeating. Five-sixths is equal to 0.83 repeating. Now what happens if you have something, it doesn't stop, but you can't use that repeater bar to show the pattern? Well, this is what they call non-terminating, non-repeating. So we have rational numbers. Rational numbers can be terminating or repeating. Here's a new term for you. These are called irrational. Irrational numbers are non-terminating, they are non-repeating. Well, what in the world am I talking about here? Let me give you an example. 0.23, 233, 2333. First you have 1 3, then you have 2 3s, then you have 3 3s. What's the next thing in our pattern here? It's going to be 0.232, 332, 333, 2, 3333, 2, 33333. There's no way that you can use a fraction bar to illustrate this pattern. So even though there is a pattern that continues, it's not the same pattern that repeats over and over. Like you could have a pattern that said 0.232323232323. It's the same pattern, the same repetition. Let me show you. I don't have the fraction for this, but it's irrelevant. If I had 0.23 repeating, I would put the fraction bar, put the repeater bar over both the 2 and 3, and that indicates that my repeating decimal here is 0.23232323, as opposed to this irrational decimal here that's 0.23, 233, 23333, 23333, 23333. At some point you're going to have a 2 and 95,000 threes after it. And that pattern is going to continue forever. It never stops, and you never have the same thing repeating. When you have those conditions, those are what we call irrational numbers. And you won't be doing a lot with the irrational numbers at this point, but you do need to add that additional vocabulary definition, the additional word to your set of vocabulary that you are learning. So, it says, state whether the following decimals are terminating, repeating, or irrational. Now, irrational is non-terminating, non-repeating. So let me go ahead and show you these three. Our 45.36, 36, 36, 10.375, I'll make that 16.375, 0.58333, and right here I have 1.232332333, which I think is funny, is pretty much the one that I just pulled up out of my head. What do we have repeating here? 36, 36. So you can express this as 5.36, where the pattern of 36 repeats. So this is a repeating decimal. 16.375, that of course is a terminating decimal. This one is repeating. This one is terminating. What about this one? 0.583, different digits in there. Does that mean it's not repeating? Well, no, because what we have here, these ellipses indicates that it's 5, 8, 3s forever. So this would be represented by 0.583 with the bar only over the 3, because the 3 is the only digit that repeats, and this is a repeating decimal. Finally, down here, we have an irrational number. Irrational decimal because it neither terminates nor repeats in a manner that we can indicate by using the bar. Because 1 3, 2 3s, 3 3s, 4 3s, 5 3s, 27,000 3s. There's a pattern, but it's not the same pattern repeating, so this example here is irrational. That's all that's involved in this section. I'll see you next time.